Have you ever stopped to think that something happening 93 million miles away could actually mess with the phone in your hand? Well, it absolutely can. Today, we're talking about space weather, this invisible force from our own sun that can seriously disrupt our super-connected, tech-heavy world. All right, let's get right into it.
Welcome back. So this is part 3 in our 10-part series, and it's all based on this fantastic report. And it's a mouthful, an introduction to radio frequency interference, or RFI, electromagnetic interference, or EMI, and space weather for non-technical people. It's by a group called RFI Detectives who are part of Virtualization Options, LLC. Now, if you're just jumping in, don't worry, you can totally follow along. Today, we're tackling Chapter 3, and we're going to meet the undisputed heavyweight champion of electronic interference.
So, let me just ask you a quick question. When you think about what messes with your Wi-Fi or makes your GPS go haywire, what pops into your head? Maybe the microwave? Your neighbor's new router? Those are decent guesses, but they're not even in the same league as the real culprit. Not even close.
The real answer is 93 million miles away. Yeah, you heard that right. The biggest source of interference that impacts all of us is our very own sun. And today, we're going to break down exactly how that's even possible. Okay, so here's our game plan. First, we're going to zoom out and get the big picture on interference. Then we'll focus right in on the sun itself. We'll unpack the 3 main kinds of solar storms, look at what happens when they actually get here, and wrap up by seeing why our modern lifestyle makes us especially vulnerable.
All right, first things first. To really get a handle on how the sun can cause so much trouble, we've got to understand that this isn't just about radio signals. We need to look at the entire family of electronic disruption.
We've talked about RFI before, radio frequency interference, but RFI is really just one slice of a much bigger pie called EMI, or electromagnetic interference. The easiest way to think about it is this. EMI is the umbrella term for any unwanted electromagnetic energy. RFI is just the specific kind that messes with wireless stuff like your radio or Wi-Fi. So all RFI is EMI, but not all EMI is RFI.
And this is the whole shebang. The EMI umbrella covers this entire spectrum. Way down at the low end, you've got things like the 60 Hz home from your power lines. Then you get to the radio frequencies. That's RFI's home turf. But EMI also includes everything above that. Infrared, the light we can see, ultraviolet, and here's the important part for today, the really heavy hitters like X-rays and gamma rays. Our sun can dish out interference across this entire range.
And here's a perfect example of how that works. Imagine a solar storm hits Earth. It can create these huge electrical currents in our power lines. That's a classic case of EMI messing with a physical wire. But when that same storm blasts radiation that scrambles your GPS, well, that's RFI because it's disrupting a radio signal. Same storm, 2 different kinds of interference.
Okay, so now that we've got the lay of the land, it's time to introduce the main event. The biggest, baddest source of EMI in our entire solar system, our sun. It's not just a friendly ball of light. It's a massive, churning engine of electromagnetic power.
So how exactly does the sun cause all this chaos? Well, it doesn't just shine. It has tantrums. We call them solar storms. And there are basically 3 main flavors, and each one is a unique threat to our technology. Let's break them down.
First up, you've got solar flares. Picture a gigantic, sudden flash of light, an explosion of pure energy like X-rays and other radiation, just blasted off the sun's surface. And because this stuff travels at the speed of light, we get about 8 minutes of warning before it hits us. That's it. It's the speed demon of solar threats.
Next, we have coronal mass ejections, or CMEs. Now, if a flare is a flash of energy, a CME is the sun literally throwing a chunk of itself at us. We're talking a billion-ton cloud of magnetized gas. It moves a lot slower, taking maybe 1 to 3 days to get here, but when this massive thing slams into Earth's magnetic field, it packs one heck of a punch. And finally, there are solar energetic particles, or SEPs. You can think of flares and CMEs as the cannon, and these particles are the cannonballs. They're tiny subatomic particles that get accelerated to near the speed of light. And these are really, really bad news for our satellites. They're like microscopic bullets that can tear right through a spacecraft's shielding and fry its electronics. So we have these 3 types of solar storms, but what actually happens when they get here? Let's connect the dots from these cosmic events to the very real consequences we can feel right here on the ground. This lays it out pretty clearly.
Those big CMEs can pump so much energy into our power grid that they damage transformers and cause huge blackouts. The solar flares and those energetic particles can bombard GPS satellites, making them less accurate or lose signal altogether. And for airplanes flying over the poles, a solar flare can knock out their high-frequency radio communications. It's serious stuff.
And I really want to stress this. This is not a sci-fi movie plot. We are not talking about what-if scenarios. These are known, documented weaknesses in the exact systems that run our economy, our navigation, and pretty much all of our global communications.
Which brings us to our last section. The sun's been doing this for billions of years, so what's different now? Well, we are. Our society's deep and growing dependence on technology is what turns space weather from a scientific curiosity into a major risk.
I mean, just think about your own house for a second. The average American home has over 20 connected devices now. Your phone, smart speaker, thermostat, doorbell, every single one is a little node in this giant global network that's vulnerable to this kind of cosmic event.
And here's the kicker. The more wireless tech we pack into our world, the more crowded and noisy our airwaves become. Engineers call this rising background static the noise floor. Think of it like trying to have a conversation in a really loud room. You have to shout to be heard. Our devices are constantly shouting over this noise, which makes them even more sensitive when a huge blast of energy from the sun comes along and just overwhelms everything.
So, I'll just leave you with this thought to chew on. We are building this incredible, interconnected, so-called smarter planet. Our daily lives are completely dependent on a fragile web of technology. But as we race to build that future down here, are we remembering to look up and account for the powerful, unpredictable star that could unravel it all?